All right, welcome back to my channel, everyone. So now we are continuing our discussion. So the previous meeting we discussed about still in the solution and aqueous reaction. However, the previous question that we discussed is around like just the study question. Now we are dealing with the real question of ACS exam. Okay, the real equation of ACS exam. Okay, now let's get started for number one. Okay, so this question is about the hydrogen bond again. Okay, which pair of compound will form hydrogen bond with one another? Okay, so we recall our materials here that hydrogen bond, okay, hydrogen bond requires two, okay, requires two, okay, a hydrogen, okay, hydrogen bond with FO or N, okay, and then number two, another molecule with lone pair. Okay, no, it can so another molecule with lone pair to accept the H bond. So another molecule can with lone pair. Okay, with lone pair, with a lone pair. Okay, we pause for a while. Right, so let's tackle for the first question first. Okay, so the question is ask about the hydrogen bond. Okay, let's break down the choice one by one. So CH4 and H2O. Okay, CH4 and H2O. So CH4 is non-polar. Okay, non-polar. So no H bonding to nor or acceptor. So there is no H can to nor or can be acceptor. So the A option is wrong. And then again CH4 again. Okay, CH4 doesn't participate in hydrogen bond, so we can eliminate this one. How about the HF and CH4? Again, CH4 can't. Okay, and then the last one is an H3 and H2O. Okay, so both both okay both elements, both molecule have hydrogen bond, right? Attached to N or O. Okay, attached to N or O. And there is also lone pairs. Okay, there is also lone pairs over here. Okay, there is also lone pair, which is perfect for hydrogen bonding. Okay, so remember the requirement to be hydrogen bond, like there should be there is a bonding between H and one of these atoms. And then for the second one, another molecule with a lone pair on N or O or F to accept H bonding. Okay, to accept H bonding. All right, just quick tip, look for H. Okay, just quick tip, look for H. Okay, attach N, O or F. Okay, and lone, there is also lone pair. Okay, on another N, O or F nearby. That's hydrogen bonding. Okay, now number 2. Which pair of compound will form hydrogen bond with one another? Again, we need to take a look at HFON first. Okay, how about the option A? There is no hydrogen bonding. How about the B option? CCl, and H. There is no hydrogen bonding. How about this one? Okay, we have OH over here. Okay, we have OH over here. And then we need to look at for another option again. Okay, we have OH. However, we don't have, okay, we don't have any kind of donor or acceptor in CH4, so it would be not, it wouldn't be this option. How about another one? We have OH and then we had NH, so like we can like determine the answer very quick. Okay, so number 3, what would be expected to be the most soluble in ethanol? Okay, so now we are talking about the soluble one. And then remember the fundamental of dissolve. All right, so we need to look at what type of ethanol. Okay, what type of ethanol, the characteristic of ethanol itself. Okay, ethanol is polar. Okay, is polar. Ethanol is polar, and then it has hydrogen bonding. Okay, can form hydrogen bond. Okay, can form hydrogen bond. So now let's compare with each option. Okay, let's compare with each option. Now is this one is propane. Yeah. So propane is non-polar. Okay. So not compatible because propane is hydrocarbon. So this one is non-polar. It's very saturated. Okay. It's saturated. So non-polar. So not compatible with polar ethanol. And then how about the CO2? CO2 is polar, right? Wait. CO2 is polar? No, CO2 is non-polar. Okay, kind of like this, right? Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Yeah, kind of like this. Okay. Um, is linear and then symmetrical, so it will be non-polar. So the answer will be I mean we can eliminate the option CO2, then option this one. How about now NH3? NH3. So as you can see, NH3 has lone pair. Okay, so it will be polar, and then two. Does it has was that hydrogen bonding? Yes. Okay, a H N N. Okay, it has H N N. So it will the answer will be C. How about the SF6? Okay, this is completely non-polar because as you can see, SF6 kind of like this. This is non-polar because this one is symmetrical. Okay, because this one is symmetrical, and then we can like say this one is cancel out. Okay. So now number 4, which substance is most soluble in water? The same concept. Water is what is the water? Water is polar, okay? H2O. And then it also has what's that? It also has hydrogen bond. Okay, now let's take a look at the option. The first one we can cancel. I mean we can eliminate, as well as for option C because both are a hydrocarbon. Okay, both are hydrocarbon. And then now let's take a look at for B, option B. Okay, option B, ethanol, it's polar and then it has hydrogen bond as well. So we guess the good, I mean the correct option should be B. And then how about the butanol? Okay, butanol is, as if you are may add propose, so butanol will be like this way. Okay, O and then H. Okay, and then H and then H over here. So this is CH2. Okay, so let's see which one that the long. So butanol has longer tail. Okay, longer tail or longer chain. We can say longer chain. So this one is less soluble. The question is which one that the most soluble. Okay, so P. Just remember, just quick tip. Smaller, okay, more soluble. Remember this was that more soluble within water, okay, and then longer or shorter, okay, we can say the shorter, this is longer, is more non-polar. All right, okay, and then this one is less solubility, right? Okay, that's good. Okay, now let's continue for number 5. Okay, consider the structure of vitamin A. Vitamin A should be insoluble in water and in oil, less soluble in water than in oil, equally soluble in water and in oil, and then more soluble in water than in oil. So, to answer this question, we need to understand the key concept of the solubility. Okay, let's take a look at the vitamin A structure first. See, it has the hydrogen bond over here, OH, okay? The vitamin C only one OH group at the end, okay? And then a lot of CH bond, which is hydrocarbon change, okay? That means, okay, this means like mostly non-polar, okay? Mostly non-polar. Just want to double check for the answer number 4 and 3. Number 4 is B, number 3 is C. Yeah. Number 2 is D. Yep. Right. So let's take a look at number 5. Okay. Mostly non-polar. And then okay, mostly non-polar, which is hydrophobic. Okay. Hydrophobic. And then the last part is there is also a polar region in OH, okay, which is OH group at at the end, okay. So now let's compare between water and oil. So water is polar, okay, water is polar, and then oil is non-polar. So mostly, because mostly is non-polar, so vitamin A will will like vitamin A is more soluble in oil, okay, more soluble in oil because non-polar, okay, rather than in water. So the answer will be more soluble, uh more soluble in, okay, less soluble in water than in oil. So the answer will be B. Number 5, the answer will be B. Yes. Because of what, like I mentioned, we need to identify the vitamin A characteristic first. We get the characteristic which is there is a OH bond at the end of at the tail, okay? Just a tiny polar group over there. We indicate that okay, this one's still soluble. However, the structure is most likely more likely non-polar, okay, which mostly non-polar, so it's much more soluble in oil because oil is non-polar, red instead water because water is polar. Okay, number 6, the mass percent of acetic acid in bottle blah 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 blah. What is the molar concentration of acetic acid in vinegar, assuming the density of vinegar is 1.005 gram milliliter? Okay, we already done for this question. We already got, I mean, we already had this type of question before. So acetic acid is only 5.45, and then we need to know the water. Again, water is the remaining one. We assume we have 100, so just 100 minus this one, so it will be what? Okay, let's continue later on. Okay, All right. So let's continue our discussion. So now we have another question about the mass percent of acetic acid, blah blah blah. So we know we need to determine the sorry. We need to determine the mass of water. Okay? 100 times minus 5.45. So it's around 9455%. Okay? This is for water. And we assume that we have like so just remember molar concentration. Okay? Molar concentration is mole divided by kilogram of what? Kilogram of this is molarity. Oh yes, this is molar concentration, not molality. So we have another type of question. So this is molar concentration of the solution. I think this should be same. Okay, it should be in kg. Okay, it should be in kg or in liter. It's same, right? Kg or mole per liter. Okay, so it depends on the question. Okay, it depends on the question, but remember it should be in kg or in liter. Okay, so now um the question is, what is the molar concentration of acetic acid in vinegar, assuming the density is 1 point, okay, blah 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 blah. So what we want to know here is the density. This is the density of vinegar. This is okay. The mass percentage in bottle of vinegar is okay. So rho and then m per v. Okay, rho m per v. All right. So we will need to know the mass of acetic acid first. Okay, the mass of acetic acid first. How to get that one is uh mass rho times v. Okay, so we know that we assume the we have like 1 liter. Okay, because this is 1 liter, right? So rho should be 1.005 times 1 liter, which is 1000 milliliter, right? Then oh, this is vinegar. Okay, let me. This one is milliliter. This one is gram per milliliter. So we can cancel out milliliter. So we ended up getting 105 gram solution. Okay, 105 gram solution. Like 1005 gram solution. Now we already knew the we need to convert it to mole. Okay, convert this one to mole. So just gram per mole. So this one divided by 60.06. So in gram it will be no way. So we need to know the mole, right? This is 105 gram. So we know the gram. So and then gram. So Okay. Let me clarify or revise again to make it easier for us to make easier. Okay, the first step, assume we have like 1 liter. Okay, assume we have 1 liter sample. So now we need to determine the acetic acid itself. Okay, the mass of acetic acid in 1 liter. Okay, so we need to assume 1 liter of solution. So mass is 1.005 gram per milliliter times 1000 milliliter. So we will have mass like 105 gram of solution. We have total around this one. Okay, the mass percent of acetic acid in bottle is, oh, okay, so the total of solution is this one. Okay, and then we have around like 5.45. So now the mass of acetic acid is 5.45 times 105. So it will be around 0. Why this one? It make me confused. Okay, let's use 100 probably. Let's use 100. For example, assume we have 100 milliliter. Okay, 100 milliliter of solution. So the total mass is 1.005 times 100. So it will be 105 gram. Okay, I think this one is still same. However, it will be easier for us to follow it. So now 5.45%. Okay, the mass percent of acetic acid in bottle. Okay, let me clarify. Okay, let me clarify. So we are as a vinegar solution contain 5.45. Okay, 5.45 acetic acid. Okay, by mass. And then we have density, then others. Okay, so what does this mean? Okay, what does this mean? This mean in every 100 gram, in every 100 gram there is 545 gram acetic acid. Okay, acetic acid. Okay, to calculate molarity, we need mole of solute. Okay, to calculate molarity, we need to have mole of solute, which is acetic acid. Okay, and then we need to have liters liters of solution, right? Okay, let's assume we have 1 liter. We have 1 liter because in the equation we know that m is mole per liter or mole per kg. Okay, so assume we have 1,000 milliliter. Okay, because molarity is mole per liter, and using 1 liter to simplify, okay, using 1 liter simplifies the math. Okay, so now find the total mass of 1 liter of solution. Okay, 1 liter of solution. How to do that is pretty simple. The total, okay, the total is 1.005 gram per milliliter times 1 liter, 1,000 milliliter. We are ended up getting 105 gram. Okay, the total of solution by mass, okay, is 105 gram of solution. Now we need to take a look at the mass of acetic acid. Okay, we need to find out the mass of acetic acid in 105 gram. How to do that? Okay, mass is 5.45 times 105 gram. Okay, so the answer will be 45.77 gram. So we know in 105 gram of solution there is 54.77 gram of acetic acid. Okay, so now let's convert it to mole. Okay, convert it to mole. It's pretty simple. Just this one divided by 60.06, and then we will get mole is 0.912 mole. Okay, now we need to know, now we need to convert mole into molarity. Okay, convert, after we are getting moles, we need to convert it into molarity, which is, for molarity is 0.912 divided by 1 liter. Okay, so the answer will be 0.9112. So the answer will be D. Okay, all right, so hopefully it will more understandable. So now let's take a look at for number 7, 8, and 9. Okay, again we are facing again same thing. A 250 milliliter bottle of sport drink solution contains, so the total is 250 milliliter, contain 4.5 mass of sodium chloride in ACN. What is the molar concentration of sodium chloride in this bottle of sport drinks? Okay, now assume we have we assume we have 250. Okay, 250. However, okay, however, there is no information of the total of the the total of solvent. Okay, the total of solution. No, there is no information the total of solution. Only 250 milliliter. However, there is information here that says, okay, just let me clear. Number 6 is D. Yep. Okay, let's move on. So we have like 4.5%, and then assume we only have like 100 gram of solution. Okay, of solution. So now just 4.5, so it's around 5, right? And then this one and this one. So 0, 4, 6, right? So it should be 5, and then 95.5, okay, gram of water. Okay, so we have like another one, so 95.5 gram of water. And then we need to know in kg, okay, n per kg or n per liter. Now let's take a look at if we have using the mole, if we have like 4.5 gram, the question is sodium chloride, right? Divided by 58.44, this is the mole. So the mole is what? The mole is 0.77 mole, okay? And then we need to convert it to molarity, okay? Molarity. So for M is 0.77 divided by how much it is for the solvent. For the solvent is this one. However, we need to convert it into kg. So it's around 0.0955. Okay, this one is 0.0. Okay, 0.0. 0.0. Yeah. So 0.0955 kg. So the answer is around 0.806 molarity. Okay, so we can ignore for the percent mass, always assume 100 gram of solution. Actually, we can do the same thing over here, right? We can do the same thing, but however, we use the 1 liter to make it easier for us. So see, if there is no information about like in this case is by mass, okay, for percent by mass, remember there is a concept over here that if the equation is percent by mass, we need to use we can assume 100 gram, and then this one is percent by what? Percent by mass and density. Okay, mass and density. Okay, so in this case it's different. Okay, just want to simplify the math itself. Okay, now number 8, like 1400 gram sample of stream water contains 12.2 ppm. What is the mass of Hg, okay, mercury in the sample? Okay, let's take a look at this one. Okay, now we need to convert, okay, 12 ppm. 12 ppm, it means it tell us like 12.2 milligram in 1 kg. Okay, so just remember 12.2 ppm is milligram in kg, and then the sample size is 1400. Now we need to take a look at the information. Okay, use the first step is using the 12.2 milligram, okay, divided by 1000, because in this case we can see in 1 kilogram, we need to know like in milligram. Okay, in the, sorry, this is, you can use 1000 or you can use because in this case it's gram, we can use gram over here. So we know okay, so we want to know this part, right? So x in, okay, this is in milligram, right? It will be in milligram in 400 gram. Okay, so how to get this one is easy. Just x, okay, 400 gram. So let's clarify again. So ppm, which means 12.2 milligram in 1000 gram. However, we have 400 gram, right? We have 400 gram, and then we want to know how much it is over here. Okay, how much it is over here. So now, how to get this one? Just pretty simple. We can cancel out this one. 12.2 times 400 divided by 1000. So we can cancel out this part. Okay, 12.2 times 1.4. 12.2 times 1.4. So the answer will be 17.08. Yes, the answer will be D. Okay, just remember the concept. ppm is milligram per kilogram. Okay, remember, ppm is milligram per kilogram. All right, so what mass of water is needed to dissolve 292 gram of NaCl to produce a 0.25 m aqueous solution? The question is, what mass of water is needed to dissolve this one? Okay, you can use the formula like mv and mv, I think, or we can use just the simple equation, I think. Okay, now let's take a look at for the mole first. 292.5 divided by 58.44. So 292.5 divided by 58.44. So the answer is around 5.005 mole. Okay, and then to produce 0.25 molarity, so the molarity itself is 0.25. All right, so the question is mass of water. Okay, mass of water. So we know the m is 0.25 divided equal 5.005 mole, and then we want to take a look at x over here in kg. Okay, it's pretty simple. Just divide it by 0.25. So the answer will be x will be 20 kg. Okay, around 20 kg. So number 9, it should be A. Yep, good. The density of okay, we need to know the density blah 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 is okay. The rho of HNO3 is 1.150 gram per milliliter, and then we know the molarity is 3.539. Okay, and then the temperature is 20 degrees Celsius, but there is no, I mean, there is no correlation, I think, between I mean, in this case, for, let me, what is the molar concentration? We know the molarity, right? We know the density. So first, what we want to know is, assume for molar concentration, we can, this is the milliliter, right? We can assume we will use like 1,000 milliliter, okay, 1,000 milliliter. So we have also density, okay, like the previous equation. So in 1,000 milliliter, like how about the mass itself? Okay, the density of this one is, so the total is what, gram per milliliter. So this is milliliter, right? So we can cancel out this part, and then 1.150 times 1,000. So the answer of this is 150 gram of solution. Okay, we have the total is 115, okay, 1,150 gram of solution, right? Okay, and the question is, what is the molar concentration? Now we need to look at the mass itself, okay, mass of HNO3. How to get this one? We know the density. This is we know that we already have the mole, right? Yes, this one is mole. 3.539 mole divided by 63.02. So like I mentioned, mole is gram per mR. So we, to get the gram is mole times, okay, sorry, mole times is mole times mR. Mole is what, 3.539 times mR is 63.02. So we can get the mass is around 223.1 gram. Now we need to know the mass of water, right? We need to know the mass of water. We know the mass of HNO3. No mass water. It's pretty simple. Just this one minus this one. So it's around like 96.9 gram. So around 0.926 kg. Okay, kg. Okay, now we need to know the molarity. It's pretty simple. We just put in the mass of the mole. Okay, the mole of this one, 3.539 divided by what, 0.96926. So the answer is around 3.818 p. All right, so just remember that we need to know, use density to get the total solution mass, and then subtract solute mass to get the solvent, okay, then plug into the molality formula. Okay, now the solubility of substance is 60 gram per 100 milliliter of water. A solution of this substance is prepared by dissolving 75 gram in 100. Okay, the solution is then cooled slowly to 15 without any solid separating. The solution itself is, okay, now we need to know at the logic. Okay, at 75 degrees Celsius, okay, more than 60 gram dissolve. The solubility So 60 gram will dissolve, okay, at 75 degree. Okay, so more than 60 gram can dissolve because the 75 can dissolve very well, okay. And then when it's cool to 15 degrees Celsius, only 60 will dissolve, but not solid, okay, no solid precipitate. So we can assume that all of them 75 gram is also dissolve. That means the solution is holding more than it should at the temperature. That definition of supersaturated solution. At what? At 15 degrees Celsius. Okay. Okay, so if solution holds more solute than it should at given temperature without crystallizing, it's super saturated. Okay, so this is the answer. So we have kind of like more question now. So let's take a look at for number 12. A student mix 20 gram of salt in 100 gram of water at 20 degrees Celsius and obtain a homogeneous solution. Which salt could this be and why? So you know the salt itself is, oh, which salt? Okay, there is also salt information, which is KCl and then KNO3. Okay, KCl and KNO3. So now the concept is, we know that 100 gram. So homogeneous solution, which mean the salt is dissolved completely, right? Dissolves completely. So it is unsaturated, okay? Unsaturated. Student mix. So if obtain homogeneous, it will, so all of salt will be dissolved. Okay, all of salt will be dissolved, and we can, which mean unsaturated. Mm-hmm. A student mix 20 gram of salt. Solubility at 20 degrees Celsius in 100 gram of water. So KCl, we have like 20 gram of in 100 gram of water. So KCl will be dissolved when it achieves 10 gram, and then KNO3 30 gram. Okay, so KCl max, it can dissolve 10 gram. 20 gram is more than solubility, so it will be giving us like heterogeneous solution. However, KNO3 maximum is 30 gram. Okay, the solubility is maximum is 30 gram. So when we adding just 20, it will be dissolved completely. So we can eliminate option A and B, and now we have option KNO3 because this one is unsaturated. Okay, so if the amount added is below the solubility limit, this is the solubility limit. Okay, it dissolves completely or unsaturated solution. Number 13. Okay, the solubility of carbon dioxide in water is very low because the partial pressure is only 0.0030. What partial pressure carbon dioxide is needed to dissolve 100 milligram of carbon dioxide in 1 liter of water? So we can use the Henry's law, which is CKP. Okay, C is solubility in mole per liter, and then P is pressure, and K is constant, Henry's law constant. So it's coming from C per P. So we have P here is P is what? P is 0.00030 atm, right? The solubility C itself is 1.05 times 0.5 molar. Okay, now we need to take a look at the K. Okay, the K, the constant is C divided by P. So it's around 0.035 mole per liter. Okay, mole per liter atm. Okay, now we want to dissolve like 100 milligram of carbon dioxide in 1 liter of water. So now let's convert 100 milligram to moles. Okay, so moles is like gram per 0.1 gram divided by a molar mass of carbon dioxide, which is 44. So it's around 2.27 times 10 minus 3 mole. Okay, we already got the mole. So now we know that. Okay, we know that. So we know that the C. Okay, we just need to put in over here for C. Okay, for C is 2.2. Question is, what's the partial pressure? The partial pressure. So we need to look at C first. Okay, C is mole per liter. Okay, we need to know the C. So 2.27 times 10 minus 3. And then we have like 1 liter of water. So C is 2.27 times 10 minus 3. Okay. What's the C? M, right? Over here, M. So now let's move on to get the partial pressure. To get the partial pressure is easy. Just P C divided by K. Okay, P C divided by K. C is 2.27 times 10 minus 3 divided by K. K is 0.035. So P will be around 0.0649. So the answer will be A. Okay, solubility goes up with pressure. Okay, solubility will goes up with pressure. And then remember, to find out how much pressure needed, we need to use the Henry's law, which is P C K. Remember this concept, this equation. P is pressure, C is molarity. Okay, C is molarity of like the solubility in mole per liter. Sorry, C is solubility like mole per liter, right? K is Henry's constant, which is coming from what? C per P. Okay, C per P, or Henry's constant. Okay, how will you increase the solubility of oxygen in water? The partial pressure of oxygen is 0.21 in air at 1 atm. To increase the solubility of oxygen, so remember P, C, and per K. So this is the solubility, right? To increase solubility, we need to increase the pressure. Okay, we need to increase the pressure. Okay, increase the pressure. O2. Okay, so we can eliminate option B and D. One atm. BCK. Okay, so we need to increase the oxygen solubility. We need to increase PO2, right? The partial pressure of oxygen, not decreasing. So just pretty simple, because we don't need to, we don't need for the C option. Px I don't know, Px doesn't necessarily affect of oxygen partial pressure, right? So doesn't matter. This one is doesn't matter. So just focusing on, like, concerning on O2, not X. Okay, just quick tip that gas solubility increase when partial pressure of that gas. Okay, when the partial pressure of that gas increases. Okay, or we can do lowering temperature. Okay, lowering temperature in the solution. Okay, I remember that we can lowering temperature in the solution. Okay, kind of like a soda cane. Okay, when we are lowering temperature, we can increase the solubility of oxygen. All right. Okay, now let's move on to another part. A 2.5 grams sample of naphthalene was dissolved, right? What is the freezing point of the benzene solution? Okay, now we need to remember delta TF I. Okay, I, and then we know was that the the concept that I already taught, this one, I, KF, and then M. Okay, KF and then M. I, KF, and then M. Okay, The question is, what is the freezing point of the benzene solution? Okay, first in first, we have to find out the mole of solute. Okay, mole of solute. Moles of solute. How to get that one? We know the mass is 2.5 gram divided by 128.770. So it will be ended up 0. And okay, it will ended up 0.0195 mole, right? Let's move on to another parameter. Okay, this one is still mole. We need to get the molality. Okay, so to get the m or something like it should be same, right? Should be molal. This one is molality. Okay, this one is molality. Okay, m here is molality. Molality, not mole. Okay, not mole. So just 0.0195 divided by how much it is? 100 gram, which is 0.1 kilogram. So the molality is around 0.0195 m. Okay, and then because this one is it should be 1, right? It should be 1. There is no was that in the previous one? Where is the equation? Okay, this one. Okay, this one. Okay, more ions is more freezing point. Okay, more freezing point. Okay, because this one is non-electrolyte, so it will be only only 1. So same thing with this one is only 1. So 1 kf is what it is? 5.07 degrees Celsius m minus 1, and the molality is 0.0195 m. So we can cancel out this one. Then for delta Tf is just times those values, and then we ended up getting 0.989 degrees Celsius. Okay, so the answer will be B. Oops, sorry. We have another okay, the freezing point of benzene solution. The freezing point of pure benzene is this one. So T final is 5.45 minus 0.989, so it's around 4.49 degrees Celsius. So the answer will be C. Okay, we need to be careful when checking for the last part, because sometimes we just we got the answer, however we need to do one more step. All right, number 16. A technician has to measure osmotic pressure of solution to determine the molar mass of covalent solute. Which other information will need to be measured in order to determine the molar mass? The molar mass. The molar mass. The molar mass. MR. The molar mass. Osmotic pressure. Is the measure osmotic pressure. So we have information about P for the pressure. And then, you know, the osmotic pressure, the equation is P M R T. So this is M is molarity, okay, and then R and then T. We need to have to get the molar mass. Okay, to get the molar mass MR, we need to know the mass and then moles. Okay, mass and moles. Okay, so to get moles, we need to have temperature. Okay, and then we need to get the volume. Okay, to get the yeah, we need to know the volume. So you see, we to get the moles over here, right? To get the molarity, we need to molarity in this case we need to know the volume, right? So because the moles did by volume, no, yeah, in liter probably. And then mass of mass of solute, okay, mass, this one, okay, so all of them. Okay, number 17, a solution was made by adding 800 gram of ethanol to water. How much would this lower the freezing point? Okay, so the freezing point, delta TF, and then I KF, and then molarity. So the I itself is 1, KF is 1.86. How about the molarity? So M is coming from what? It's coming from moles divided by the total of solute in kilogram. In kilogram. So now we have a 800 gram divided by um divided by what? Molar mass ethanol is 46.07. So it's around 17.37 mole. Okay, we already got this one, 17.37 mole. And then the total of, okay, the total of the solution is 8 kilogram. Okay, so 8,000 gram is 8 kilogram, so it will be 2.17, so just 2.17, and we get the delta F is around 4.04 degrees Celsius. So the answer will be B. Which aqueous solution will have the lowest osmotic pressure? Remember, osmotic pressure is MRT. So now it just depends of M itself. Okay, which one that the lowest one? So the lowest one is A. So the answer directly A for number 18. Oh, let me see the osmotic pressure. Oh, there is a I. Okay, there is a I. It should be there is a I over here. Like, okay, let me revise this one. PIMRT. Okay, remember this one. Okay, this is the original formula. If the osmot, this one, you know, this one is 3, right? 3, 0.04 for the option A. For the option B is 2 times 0.05. This one is 0, this one is 12, right? This one is 1, 10. Okay, so, and then another one is more than that. Okay, so the answer will be P. Okay, the answer will be P. Okay, just remember, for colligative properties like osmotic pressure, always count particles I. Okay, I, and multiply by molarity. Okay, number 19. Consider pure water spirited from aqueous sugar solution per ml per membrane. After some time has passed, what if anything will happen to concentration of the sugar solution? Pure water spirited from aqueous sugar solution by per ml. After some time has passed, what if will happen to the concentration of sugar solution? The concentration of sugar uh sugar will be flows toward more concentrate, right? Osmosis. So we have pure water one on one side and sugar solution on the other, spirited by permeable. Okay, kind of like this one. Okay, this is sugar, this is water. So water flows into the sugar to dilute it. Okay, volume of water in sugar solution is increased. Volume of water in sugar will increases. So sugar concentration decreasing. So number 19 will be P. Yeah, will A. All right. So pure water spirited from some permeable after some time has passed. Oh, the water pass. What will happen to the sugar? It will be decreasing. Okay, it will be decreasing. The sugar always water flows toward more concentrate. Okay, more concentrate. Number 20. Which solution has the higher boiling point? Glucose and glucose. Higher boiling point. In this case, only the molar mass that's different. Okay, just remember, if we have a bigger, okay, a bigger molar mass, we will have much more interaction, right? And then mole of mole of solute will increasing the boiling point. So which one that higher? So the molar mass, this one, 200 divided by n is 1.11. Okay, and then 200 divided by 342, it will be 0.5 mole. So which one that higher mole? So the solution one will be has the higher boiling point. Okay, that's good. Okay, we done for today for this solution and aqueous reaction part 2. And then for the next part, we will discuss about the next chapter, which is about kinetics energy. Okay, about the kinetics. Okay, much more challenging. And then we have kind of like a bunch of formula, a bunch of concept that we need to remember. Okay, so okay, see ya, bye bye, see you next